1.5 million kilometers from the blue marble of Earth, the sun hangs as a relentless blinding eye, yet here, in the shadow of the world, the temperature plunges toward the absolute floor of physics. This is the second Lagrange point, a gravitational island in the velvet black where the pull of the Earth and the tug of the sun reach a silent, perfect truce. In this stillness, there is no air to carry a sound, no wind to stir the dust, only the crushing weight of an infinite vacuum. It is a desert of absolute zero, a place so cold that the very motion of atoms begins to stutter and fail. Into this lightless theatre, a silent traveller has arrived. It does not possess the clattering gears of the industrial age, but moves with the grace of a predatory flower. Shrouded in 5 thin layers of silvered plastic, each no thicker than a human hair, it creates its own private night. On one side, the heat of the sun rages at hundreds of degrees. On the other, just centimetres away, the darkness is so profound that it mimics the conditions of the deep space between galaxies. This is the sanctuary of the Golden Sentinel. The transformation begins in the hallowed quiet. Without the intervention of human hands, the structure begins to breathe. A central spine extends, and the great sunshield unfurls, a silver kite the size of a tennis court, snapping taut against the void. Then, the centerpiece reveals itself. 18 hexagonal plates coated in a layer of pure gold just a few hundred atoms thick begin their slow, mechanical dance. These are not mere mirrors. They are the facets of a singular massive eye. They pivot on motors that move with the precision of a few nanometers, shifting by fractions of a hair's breadth until they form a perfect concave honeycomb. As the final mirror segment clicks into its designated home, a phantom vibration ripples through the carbon fiber bones of the craft. The golden bloom is complete. It stands 6.5 meters across, a gleaming metallic blossom reflecting nothing but the ancient stars. It is now a singular entity, a basin designed to catch the rain, of photons falling from the beginning of time. It waits. The silence here is not empty. It is expectant. The telescope is a lung, held in a permanent state of inhalation, waiting to draw in the first gasps of a universe being born. The light it seeks is not the light we know. The photons that left the first stars 13.8 billion years ago have been travelling through an expanding universe for so long that they have been stretched and tortured. What began as brilliant ultraviolet fire has been pulled into the long invisible wavelengths of the infrared. To our eyes, the space between the stars is a black graveyard, but to this golden eye it is a riot of heat and history. These are the stretched whispers of the dawn, the red-shifted ghosts of the first suns to ever ignite in the dark. The sentinel stares into the great nothing. It looks past the familiar constellations and the local dust of the Milky Way. It pierces the veil of the present to witness the frantic, violent childhood of the cosmos. Every second it gathers the energy of light that has crossed the abyss of billions of light years, light that has survived the rise and fall of entire galactic empires, to finally find its rest against these 18 golden plates. This is the threshold of the known. Beyond this point lies the era of the first light, where gravity first began to sculpt the chaos of the Big Bang into the shapes of galaxies. The James Webb Space Telescope hangs suspended in its gravitational cradle, a monument to the audacity of a species that refuses to be limited by the horizon of its own planet. It is a bridge built of gold and glass, spanning the distance between a small blue world and the edge of everything. In the absolute cold and the deafening silence of the second Lagrange point, the eye is open. The vigil has begun. The story of the universe is about to be read from the very first page, written in the faint warm glow of ancient embers. We are no longer looking at the stars. We are looking through them, past the curtains of dust that have hidden the secrets of our origins for as long as humans have walked the earth. The golden mirrors do not just reflect light, they reflect our hunger for the truth. In this frozen corner of the solar system, the hunt for the first fire has commenced, and the silent deep is finally forced to give up its ghosts. The machine operates with a chilling precision, its sensors cooled by liquid helium to temperatures just a few degrees above absolute zero. This extreme refrigeration is necessary because the telescope itself must not glow with its own heat. It must be as cold as the void it observes to detect the faint thermal signatures of the distant past. It is a ghost hunting ghosts. Every mechanical movement is a calculated risk, a testament to decades of human labour and the relentless pursuit of the unseeable. The golden eye is now the most sensitive instrument ever conceived, capable of detecting the heat of a single bumblebee at the distance of the moon. It is tuned to the frequency of the ancient cosmos, ready to translate the infrared secrets of the dark into a visual language that the human mind can finally comprehend. As it settles into its long watch, the telescope prepares to peer into a specific patch of the sky, a region where the shadows are thickest and the mysteries are most profound. This is where the largest star factory in the history of the universe lies hidden, waiting for the golden bloom to strip away its veils and reveal the industrial heart of the heavens. Long before the golden eye opened its faces to the deep, humanity remained tethered to the narrow boundaries of its own biology. For thousands of years, the night sky was perceived as a static and eternal tapestry, a fixed firmament where stars were thought to be immutable jewels set against a backdrop of perfect, unchanging velvet. This perceived permanence was a symptom of our limited perspective, a byproduct of a species that lives for only a handful of decades, observing a cosmos that breathes on a scale of billions of years. To the early watchers of the night, the dark patches scattered across the luminous river of the Milky Way were not seen as the matter, but as absences. They were regarded as vast, terrifying voids where the light of creation had simply failed to take root, or perhaps as literal tears in the fabric of the heavens through which one might glimpse the true, empty nothingness beyond. In the late 18th century, the astronomer William Herschel turned his great reflecting telescopes toward the dense star fields of the constellation Scorpius. As he tracked the glittering density of the galactic plane, he suddenly encountered a region of such profound and absolute blackness that it seemed as though the universe itself had been extinguished. He famously recoiled from his eyepiece, exclaiming to his sister that there was truly a hole in the heavens. To Herschel, this was a localized apocalypse, a place where the stars had been swept away by some unknown celestial hand. He was a man of immense intellect, yet he was a prisoner of the visible spectrum. He could not have known that he was not looking at a hole, but at a wall. He was staring at a dense, opaque curtain of cosmic dust, a shroud so thick that it swallowed the light of 100,000 suns and refused to let a single photon escape to reach his waiting eye. These curtains of dust are composed of microscopic shards of carbon and silicates, the soot and ash of ancient stars that perished long before the Earth was a grain of grit in a protoplanetary disk. This interstellar medium is not a vacuum, but a thick, turbulent smog that permeates the galaxy. For centuries, this soot mocked the progress of astronomy. Every time a scientist built a larger lens or a more polished mirror, they were met with the same impenetrable shadows. The most energetic and transformative events in the universe, the violent birth of new stars and the chaotic assembly of planetary systems, remained hidden behind these veils. We were like observers trying to understand the inner workings of a great city, while standing miles away, seeing only the smoke rising from the chimneys but never the fire in the hearth. Our biological eyes, evolved to see the specific yellow light of our own sun, were fundamentally blind to the true nature of the cosmic machine. The transition from a belief in a static firmament to the realization that the cosmos is a restless recycling engine was one of the most profound shifts in the history of human thought. We began to understand that the universe is not a museum of finished objects, but a living ecosystem. The dark clouds that Herschel feared were not voids, but reservoirs. They were the graveyards of the dead and the nurseries of the unborn. Within those black nebulae, gravity was quietly and relentlessly at work, pulling the cold breath of the galaxy into a crushing embrace. The very dust that blocked our sight was the raw material of existence, the concentrated essence of iron, oxygen and carbon that would one day form the foundations of worlds and the bones of sentient beings. However, to see this process, to witness the transition from cold gas to nuclear fire, we had to transcend our own nature. The realization of our collective blindness brought with it a new kind of frustration. We knew that the most important chapters of our origin story were being written in a language we could not read. Behind the opaque walls of the Great Rift and the Colossal Nebula, the universe was busy at work, churning out new generations of stars in a frantic industrial cycle. We could see the light of mature galaxies and the fading embers of dying suns, but the moment of conception remained a secret. This was the great barrier of the 20th century. We were looking at a masterpiece through a layer of thick, dark paint, able to sense the texture of the canvas, but never the brilliance of the colours beneath. The interstellar medium acted as a cosmic filter, scattering the blue and green light of the stars until only the faintest, reddest glimmers remained, and even those were eventually snuffed out by the sheer density of the clouds. This historical struggle defined the mission of the Golden Sentinel. We realised that if we wanted to understand how the chaos of the Big Bang became the order of the solar system, we had to stop looking at the light and start looking at the heat. We had to build a device that could feel the warmth of the unborn stars through the freezing smoke of the galaxy. The story of our sight is the story of escaping the visible prison. It is the journey from Herschel's terrified exclamation of a hole in the sky to the modern understanding of the nebula as a frantic construction site. We have finally accepted that the most beautiful things in the universe are often those that refuse to be seen by the naked eye, and that the true heart of the cosmos beats in the infrared, pulsing with a heat that has been waiting for eons to be felt. The veil was not a mistake of nature. It was a challenge, a final gatekeeper that required us to master the laws of physics before we could earn the right to see the fire of our own creation. The reality of the electromagnetic spectrum reveals that our eyes perceive only a tiny, flickering sliver of the total light that bathes the cosmos. This visible light, comprising the colours of the rainbow from violet to red, is composed of waves so short that they are easily disrupted by the physical architecture of the universe. When these waves encounter the vast clouds of interstellar dust, those microscopic shards of carbon and silicates, the interaction is one of violent collision. The shorter, more energetic wavelengths, such as blue and ultraviolet, strike these dust grains like pebbles hitting a stone wall, scattering in every direction until the original image is lost in a haze of grey and black. To a telescope limited to visible light, these clouds are impenetrable barriers, thick curtains that refuse to reveal the secrets of the stars being forged within their depths. However, the laws of physics provide a subtle and elegant loophole. Beyond the red end of the visible spectrum lies the infrared, a realm of light where the waves are longer, slower, and more patient. These undulating waves of radiation possess a physical scale that allows them to interact with the universe in an entirely different manner. Where visible light is blocked, infrared light flows. Because its wavelengths are larger than the grains of cosmic dust, it does not collide with them, but instead slides through the gaps and around the obstacles. It moves through the densest nebulae like a master key sliding through the tumblers of a complex lock. This is the invisible language of the universe, a silent stream of information that carries the thermal signature of every object that possesses even a hint of warmth. To see in the infrared is to see the heat of the cosmos itself, bypassing the smoke of the galaxy to witness the fire of creation. The challenge of capturing this light is compounded by the very nature of time and space. The universe is not a static stage, but a stretching fabric. As the first stars ignited hundreds of millions of years after the Big Bang, they released brilliant bursts of ultraviolet and visible light. But as this light began its multi-billion-year journey toward us, the space through which it travelled was expanding. This expansion of space-time acted as a cosmic rack, pulling and stretching the travelling photons. Over the course of 13.8 billion years, those short energetic waves were elongated, their frequencies dropping as they were dragged into the deep red and eventually into the mid-infrared. This phenomenon, known as cosmological redshift, means that the history of the early universe has been effectively translated into a language of heat. The further back we look, the more reddened the light becomes, until it vanishes from human sight entirely, hiding in the long, cool wavelengths that only a specialized instrument can detect. To catch these ancient, stretched whispers of light, the James Webb Space Telescope does not rely on traditional silvered glass, which would absorb much of the infrared energy it seeks to study. Instead, its 18 hexagonal segments are plated in a thin, shimmering layer of pure gold. Gold is the ultimate mirror for the infrared universe, reflecting more than 99% of the incoming heat radiation back toward the telescope's secondary mirror and into its scientific instruments. These mirrors function not as a lens in the classical sense, but as a massive golden net cast into the dark of the second Lagrange point. They are designed to catch the rarest of prey, photons that have been travelling since the dawn of time, carrying the data of the first galaxies to ever coalesce from the primordial hydrogen. The precision of these mirrors is such that if the entire honeycomb were the size of the United States, the height of any bump or imperfection would be no more than a few centimetres. This golden net feeds its gathered light into a suite of instruments that act as a bridge between the alien reality of the infrared and the limits of human perception. Within the heart of the telescope, devices like the mid-infrared instrument and the near-infrared camera function as translators. They take the invisible heat signatures, the faint thermal vibrations of gas clouds and the glow of hidden protostars, and map them onto a scale that we can understand. This is the essence of the cosmic time machine. By capturing light that has been travelling for nearly the entire history of the cosmos, the telescope allows us to look across space and, by necessity, back through time. We are seeing the universe not as it is today, but as it was when the first structures were beginning to emerge from the darkness. The mastery required to facilitate this translation is absolute, because the telescope is looking for the faintest traces of heat from the edge of the observable universe. It must itself remain almost perfectly cold. If the mirrors or the instruments were even slightly warm, their own infrared glow would drown out the signals from the distant past, like trying to see a single candle flame through the glare of a roaring bonfire. This is why the Sentinel hides behind its massive sunshield, keeping its golden eye at a temperature of less than 50 degrees above absolute zero. In this state of profound chill, the telescope becomes a silent observer of the invisible, a machine that turns the cold, dark reaches of space into a vibrant, glowing tapestry. The veils of dust that once mocked our ancestors have become transparent, and the industrial heart of the cosmos, once hidden in the shadows, is finally ready to be revealed in all its violent, radiant glory. The birth of the golden eye was not a sudden event, but a slow, agonizing labour that spanned more than 30 years. It began as a series of sketches and theoretical whispers in the late 1980s, long before the technology required to build it even existed. To understand the scale of this undertaking is to view it as a modern cathedral, a project of such immense complexity and duration that it required a generational commitment. Like the master masons of the Middle Ages who laid the heavy foundation stones of Notre Dame or Chartres, knowing they would never live to see the light filter through the stained glass of the high nave, the architects of this telescope dedicated their entire professional lives to a machine they might never see function. It was a labour of collective intellect that unified thousands of scientists, engineers and technicians from 14 different nations, all working toward a singular, audacious goal: to build a time machine capable of witnessing the first light of creation. For 3 decades, the project was a gauntlet of near extinctions and technical impossibilities. Every component had to be invented from scratch. The mirrors had to be made of beryllium, a metal as light as aluminum but as stiff as steel, capable of maintaining its shape in the brutal cold of the deep. The sunshield had to be folded into a space no wider than a standard hallway, then unfurl in the vacuum of space without a single snag. This was not merely manufacturing, it was an act of extreme devotion. The men and women in the clean rooms worked with a precision that bordered on the religious, knowing that a single fingerprint, a microscopic fleck of skin, or a loose bolt could result in a catastrophic failure once the machine was beyond the reach of human hands. Unlike the Hubble Space Telescope, which orbited just a few hundred kilometres above the Earth and could be visited by the Space Shuttle for repairs, this new Sentinel was destined for the second Lagrange point, 1.5 million kilometres away. There would be no second chances. There would be no rescue mission. On a cold morning in late December, the culmination of these 30 years of labour was placed atop a pillar of fire. The Ariane 5 rocket, a masterpiece of European engineering, served as the chariot that would carry this delicate clockwork mechanism into the furnace of a launch. As the engines ignited and the ground shook with the roar of 1,000 thunderstorms, the collective breath of the scientific community was held in a state of suspended animation. The telescope was folded into its launch fairing like a piece of high-tech origami, vibrating with a violence that threatened to tear its sensitive instruments apart. This was the first great terror, the transition from the sterile safety of the laboratory to the brutal reality of spaceflight. Every second of the ascent was a gamble against the laws of physics, a moment where the 30 years of work and $10 billion of investment could have been reduced to a rain of burning debris over the Atlantic Ocean. But the launch was only the beginning of the ordeal. Once the telescope separated from the rocket and began its lonely trek into the dark, it entered a period of deployment that was described by those who built it as the weeks of terror. There were 344 single points of failure, mechanical actions that had to occur in a perfect, unbroken sequence. If any one of these 344 hinges, motors, pulleys, or latches failed to engage, the entire mission would have ended instantly. The world watched in agonizing slow motion as the sun shield began its deployment. This 5-layered canopy of silvered plastic, each layer thinner than a strand of hair, had to be pulled taut by a complex web of cables and motors. A single tear, a tangled line, or a jammed motor would have left the telescope exposed to the heat of the sun, blinding its infrared eyes forever and turning the most advanced machine ever built into a $10 billion ghost, haunting the orbit of the sun. Day after day, the commands were beamed across the void, and day after day, the machine responded with the precision of a Swiss watch. The secondary mirror support structure swung into place. The 2 wings of the primary mirror unfolded and locked. The 18 golden segments began their microscopic dance to align into a single, perfect surface. The tension in the mission control centers was palpable, a physical weight that only began to lift as the final telemetry confirmed that the golden bloom was fully open. The architects of this cathedral had succeeded. They had cast their intellect into the void and watched it survive. The struggle of the human spirit to understand the infinite was now mirrored in the mechanical perfection of the telescope. It was no longer a collection of parts or a line item in a budget. It was a living extension of human curiosity, standing ready in the cold silence to begin the work it was born to do. The era of waiting was over, and the era of discovery was about to begin as the first data packets, the first whispers from the industrial heart of the cosmos, started their long journey back to the world that created them. The first binary pulses of information began their descent from the cold isolation of the second Lagrange point, travelling as a stream of invisible light toward the massive dishes of the deep space network on Earth. In the quiet corridors of the processing centers in Baltimore, these packets of data were received not as images, but as a chaotic deluge of numbers, a cryptic code that held the secrets of the deep past. For decades, the specific region of the sky being targeted had been recorded by every other instrument as a profound and unremarkable void. It was a patch of darkness no larger than a grain of sand held at arm's length, a place where the visible universe seemed to have simply run out of matter. But as the algorithms began to stitch the infrared data into a visual tapestry, the silence of that void was shattered by a revelation that defied every existing model of the early cosmos. The void did not merely contain light, it screamed with it. As the golden eye tore away the shroud of gas and dust that had stood as an impenetrable wall for eons, it revealed a galactic structure of impossible proportions. This was not the faint, lonely glow of a few isolated stars, but a churning, chaotic metropolis of fire. Located at the very edge of the observable horizon, in a time when the universe was less than 1/10 of its current age, this structure stood as the largest star factory ever witnessed by human eyes. The image that materialized on the screens of the scientists was a riot of deep magentas, burning oranges and electric blues, representing a level of celestial activity that was previously thought to be impossible in such an early epoch. It was a landscape of pure, unbridled creation, a place where the laws of gravity and thermodynamics were working at a fever pitch. The telescope's infrared vision acted like a surgical blade slicing through the opaque curtains of the interstellar medium to expose the industrial heart beating within. In this region, the gas was not drifting lazily. It was being whipped into a frenzy by the sheer density of the matter around it. Thousands of suns were being forged simultaneously within a single, massive complex of nebulae. The narrative of the universe's youth changed in an instant. Instead of a slow, gradual awakening, the data revealed a frantic and violent beginning. This star factory functioned as a colossal crucible, where the weight of entire solar systems was being crushed into nuclear fusion by the relentless hand of gravity. The sheer volume of light being produced was so intense that it pushed back against the very clouds that birthed it, creating vast, hollowed-out caverns of glowing plasma that stretched for hundreds of light years. This was a nursery of giants. The stars being born here were not the small, stable yellow suns like our own, but monstrous blue-white titans, each dozens of times more massive than the sun. They were igniting in such rapid succession that the shockwaves from one birth would trigger the collapse of a dozen more nearby, creating a self-sustaining chain reaction of fire. The telescope captured the sensation of a universe in a state of emergency, a frantic rush to build the foundations of the cosmos before the initial heat of the Big Bang could dissipate. Every pixel of the image represented a theatre of war where gravity fought to pull the gas into a point of infinite density, while the newborn light fought to blow it back into the void. The discovery of this galactic engine challenged the very foundations of how we believed galaxies were assembled. To see a structure of this scale and productivity so early in time was like finding a fully formed modern skyscraper in the middle of a prehistoric forest. It suggested that the early universe was far richer in fuel and far more efficient at processing that fuel than anyone had dared to guess. The Star Factory was a testament to the raw power of the primordial cosmos, a place where the smoke of the galaxy was being recycled into the fire of the future at a rate that staggered the imagination. As the scientists stared at the glowing metropolis of the deep, they realized they were not looking at a distant object, but at a moment of supreme transformation. They were witnessing the transition of the universe from a dark, gaseous soup into a structured world of light and chemistry. The Golden Sentinel had done more than just see. It had unmasked the true face of the early heavens. The hole in the sky, that had once frustrated the pioneers of astronomy, was now revealed to be the most productive region of space ever found. Thousands of newborn suns, hidden for 13 billion years, were now shining clearly through the golden mirrors, their light finally finding a home in the minds of a species that had spent 30 years building a machine just to find them. The industrial heart of the cosmos was beating, and its rhythm was a reminder that the universe does not do anything in half measures. In the deep red of the infrared, the story of our origins was being rewritten in lines of fire, proving that the darkness was never empty. It was simply waiting for an eye capable of seeing the flame. The Milky Way, our celestial home, exists today in a state of tranquil maturity. It is a vast, rotating disk of stars and gas that has settled into a rhythmic, predictable pace of life. If one were to measure the productivity of our galaxy, it would resemble a quiet, sleepy village on the edge of a great continent. In the span of a single Earth year, the Milky Way produces only 1 or 2 new stars, slowly recycling its modest reserves of hydrogen into nuclear fire. It is a place of settled orbits and middle-age stability, where the violent upheavals of the past have mostly subsided into the steady, cooling glow of 100 billion suns. Here, in the modern epoch, the cosmos is a peaceful neighbourhood, a sanctuary where life has had the billions of years of quietude necessary to emerge and contemplate the heavens. But the gargantuan structure revealed by the James Webb Space Telescope belongs to a different, more terrifying age of the universe. This ancient star factory is not a village. It is a roaring industrial metropolis, a monstrous engine of creation that defies the boundaries of modern physics. While the Milky Way produces a mere handful of suns, this distant behemoth is churning out thousands of new solar systems in that same brief window of time. The scale of this disparity is almost impossible to grasp. For every single spark of light that ignites in our local spiral arms, this ancient factory produces 1,000 more, a frantic and relentless assembly line that operates with a veracity that is alien to our current era. It is as if the entire gas supply of a dozen galaxies were being forced through a single, narrow needle, compressed by the sheer weight of a universe that was far more crowded and energetic than the one we inhabit today. The early universe was a place of monstrous proportions and violent extremes. Shortly after the initial flash of the Big Bang, the space between things was much smaller, and the density of the primordial gas was suffocatingly high. In this era, galaxies did not grow through the slow, graceful accumulation of matter, but through a series of catastrophic collisions and rapid-fire collapses. This star factory is a relic of that hyperactive youth, a snapshot of a time when the cosmos was in a state of frantic construction. The sheer mass of gas being processed within its boundaries is equivalent to hundreds of millions of suns, all of it being funneled into a central crucible where the pressure is so immense that the very fabric of space-time seems to groan under the load. In this roaring industrial heart, there is no room for the quiet stability we enjoy. The environment is a chaotic storm of radiation and gravitational shear. The birth of a single massive star in this region releases enough energy to blow a hole in the surrounding gas clouds. Yet the density of the factory is so great that these holes are instantly filled by new avalanches of hydrogen, triggering even more births in a self-sustaining cycle of fire. It is a landscape of constant blinding light, where the night sky would not be black, but a permanent searing white. This is the monstrous nature of the early universe, a period of history where the rules of engagement were dictated by raw power and overwhelming abundance. We live in the afterglow of this era, in a universe that has expanded and cooled, its once violent fires now dimmed to a manageable simmer. The discovery of this hyperactive factory serves as a stark reminder of the savage conditions that were required to forge the foundations of our world. We are the inhabitants of a peaceful museum, looking back at the construction site where the raw materials of our existence were first hammered into shape. The disparity between our quiet home and this ancient engine reveals that the history of the cosmos is one of diminishing intensity. The universe in its youth was a place of frantic, desperate creation, a roaring furnace that spent its fuel with a reckless abandon that the modern Milky Way can no longer match. The data captured by the golden mirrors forces a recalculation of the cosmic timeline. It suggests that the first structures of the universe did not take billions of years to mature, but instead exploded into existence with a ferocity that suggests a much more efficient mechanism of growth. This star factory is the smoking gun of that efficiency, a testament to a time when the universe was smaller, hotter, and infinitely more productive. As we stare into its glowing industrial core, we are seeing the raw energy of the dawn, a period of history where the cosmos was a living, breathing machine of terrifying power, turning the chaos of the beginning into the order of the stars at a pace that makes our current galaxy seem like a still-life painting in comparison. The golden eye has not just found a distant object, it has found the engine room of the universe, and the sheer scale of its operation is a humbling testament to the violent beauty of our origins. The interior of this ancient star factory is not a place of serenity, but a theatre of extreme and unrelenting physics. Within its boundaries, the interstellar medium is a boiling cauldron of gas and dust, whipped into a frenzy by forces that dwarf the imagination. Here, gravity acts as the primary antagonist, a silent and invisible predator that seeks to pull every stray atom of hydrogen into a singular, crushing embrace. Gas clouds, each encompassing a volume of space larger than our entire solar system, are seized by this gravitational grip. They do not merely drift, they are accelerated, drawn inward with a mounting ferocity that causes the temperature to skyrocket. As the density reaches a critical threshold, the atoms at the heart of the cloud are stripped of their electrons and forced into a proximity that violates their very nature. They are squeezed until they scream in a shriek of gamma rays and neutrinos, finally surrendering to the pressure and fusing into the first sparks of nuclear fire. This moment of ignition marks the beginning of a violent ballet of radiation. The newborn star, a monstrous blue-white titan, immediately begins to fight back against the very gravity that created it. It unleashes a torrent of photons so intense that they exert a physical force, a radiation pressure that strikes the surrounding gas like a hammer. This is the central conflict of the factory, a desperate high-stakes tug-of-war between the inward pull of mass and the outward push of light. The light does not merely shine, it carves. It hollows out vast glowing caverns within the nebula, pushing the remaining gas away in a supersonic wind that travels at thousands of kilometers per second. This radiation ballet is a delicate and deadly equilibrium, where the survival of the star depends on its ability to maintain a constant explosion at its core, holding the crushing weight of its own existence at bay. The turbulence of this environment creates a self-sustaining cycle of creation and destruction. As the radiation from the first generation of stars slams into the neighbouring clouds of hydrogen, it creates massive shock waves that ripple through the factory. These waves of pressure act as a catalyst, compressing the gas in their path and triggering a new wave of gravitational collapses. It is a chain reaction of fire, where the birth of one sun necessitates the birth of 100 more. The factory is a living, breathing entity, a machine that uses its own energy to feed its insatiable appetite for growth. In the most crowded regions, the stars are packed so tightly that their solar winds collide, creating a chaotic web of magnetic fields and superheated plasma that glows with a brilliance that would blind any biological eye. Within this industrial heart, the concept of peace is non-existent. The environment is in a state of perpetual war. On one side stands the void, the overwhelming desire of the universe to remain empty, cold, and dark. On the other side stands the matter, the stubborn insistence of atoms to congregate and ignite. Every star that successfully reaches the main sequence, the stable middle age of a sun's life, is a hard-won victory against the encroaching nothingness. It is a triumph of structure over chaos. Yet even these victories are temporary. The most massive stars in the factory, the ones that drive the industrial cycle with their immense heat, are also the ones that live the shortest lives. Within a few million years, a mere blink in the eyes of the cosmos, they exhaust their fuel and perish in spectacular supernovae. These terminal explosions are the final, most violent act in the mechanics of the factory. When a star dies, it does not simply vanish. It tears space asunder, releasing more energy in a single second than our sun will produce in its entire 10 billion-year lifetime. The resulting shockwave is a physical wall of energy that sweeps through the nebula, enriching the surrounding gas with heavy elements and providing the final, crushing blow needed to start the next generation of stars. The factory is thus a graveyard as much as it is a nursery, a place where the ash of the dead provides the soil for the living. The cycle is relentless, a frantic industrial process that continues until the gas is either entirely consumed or blown out of the region by the collective fury of the stars it has produced. The golden eye of the telescope captures this carnage with a chilling clarity. It reveals that the beauty of a nebula is merely a mask for a landscape of total war. The glowing pillars and delicate veils of gas are actually the front lines of a cosmic battleground. We see the gas clouds being shredded by ultraviolet light, the newborn suns emerging like sparks from a forge, and the remnants of dead stars acting as the seeds for the next harvest. This is the reality of the early universe. It was not a place of slow, graceful evolution, but a frantic, high-speed construction site where the foundations of the future were being hammered out in a crucible of fire and radiation. The very existence of our world billions of years later is the result of these ancient victories, won in a corner of the universe where the silence was first broken by the roar of 1,000 suns. The aftermath of this stellar carnage is not merely a scattering of light, but a fundamental transformation of the substance of the universe. In the immediate wake of the Big Bang, the cosmos was a chemically impoverished place, containing only the simplest and lightest of elements, hydrogen, helium, and a trace of lithium. This was a universe of gas, incapable of forming solid ground, complex molecules, or the intricate machinery of life. To move beyond this primitive state, the universe required a forge of overwhelming power. These massive star factories, revealed by the golden eye of the telescope, served as the primary kitchens of the cosmos. Within the searing hearts of the titans born in these nurseries, the universe began the slow, arduous process of cooking the ingredients of reality. Inside the core of a massive star, the pressure of gravity is so relentless that it overcomes the natural repulsion between atomic nuclei. Here, hydrogen atoms are crushed together to form helium, releasing the energy that makes the star shine. But as the hydrogen is exhausted, the star does not simply die, it contracts, its internal temperature soaring to hundreds of millions of degrees. In this heightened state of agitation, helium atoms begin to fuse into carbon, the backbone of all known biology. Then comes oxygen, the breath of life, and neon, and magnesium. Each layer of the star acts as a specialized furnace, creating a nested series of shells where increasingly complex elements are hammered out of the primordial soup. This is nucleosynthesis, the alchemy of the heavens, where the simple is transmuted into the complex through the sheer brute force of stellar existence. The process reaches its apex with the creation of iron. Iron is the ultimate limit of stellar fusion, a stable element that marks the point where the star can no longer extract energy from the joining of atoms. When the core of a giant star turns to iron, its fate is sealed, but its legacy is secured. The star has become a treasure chest of heavy elements, a concentrated repository of the building blocks of planets. When these giants finally succumb to gravity and explode as supernovae, they do not just release light, they scatter their hard-won chemical wealth across the void. The oxygen that fills our lungs, the carbon that forms the very structure of our cells, and the iron that carries oxygen through our veins were all forged in the hearts of stars that lived and died billions of years before the Earth was born. The redshifted light captured by the James Webb Space Telescope is a spectral signature of this ancient alchemy. By analysing the specific frequencies of light passing through the gas clouds of these distant factories, scientists can identify the presence of these heavy elements at the very dawn of time. We are seeing the first instances of the universe enriching itself, moving from a sterile void of gas to a fertile garden of chemistry. This connection between the distant past and our own physical reality is the most profound revelation of the mission. The gold that plates the telescope's mirrors, used for its reflective properties, is itself a product of the same violent stellar deaths it was built to observe. Every atom in the human body, with the exception of the primordial hydrogen, has passed through the furnace of a star. We are not merely observers of this star factory, we are its direct descendants. We are the recycled ash of these primordial fires, the sophisticated remnants of a process that began 13 billion years ago in a corner of the universe we're only now beginning to see. The iron in a child's blood is the same iron that once sat at the heart of a dying blue giant, and the calcium in our bones was forged in the same frantic nurseries that the telescope now reveals in such breathtaking detail. To look at these images is to look at a prehistoric family portrait, a visual record of the moment the universe decided to become something more than just a collection of shadows. The star factory is the womb of the material world, a place where the light of the beginning was translated into the substance of the end. As the golden eye peers deeper into the infrared, it continues to trace the lineage of our own existence, proving that the story of the stars is, in the most literal sense, the story of ourselves. We are the way the universe finally found to look back at the forge that made it, a sentient echo of a scream that began at the edge of time. The stars that dominate the landscape of this gargantuan factory are not the patient, yellow lanterns of the modern age, but profligate monarchs that rule with a blue-white intensity. In the hierarchy of the heavens, mass is destiny, and these titans possess mass in an abundance that borders on the obscene. Because they are so large, the gravitational pressure at their centres is millions of times greater than that of a typical sun, forcing them to consume their hydrogen fuel with a reckless and extravagant speed. Where a smaller star might husband its resources for 10 billion years, these giants squander their entire existence in a mere few million. They are the briefest of candles, burning with a searing ultraviolet brilliance that illuminates the entire nebula, yet their very splendour is a guarantee of their imminent destruction. Every one of these massive stars is a ticking time bomb, born with a fuse that was lit the moment the first atoms of hydrogen began to fuse. There is no possibility of a quiet retirement for such objects. They are physically incapable of fading away. As they race through their life cycles, they transition from the fusion of hydrogen to the burning of heavier and heavier elements, each stage shorter and more desperate than the last. The star becomes a layered onion of nuclear fire struggling to maintain its outward pressure against the ever-increasing weight of its own mass. The ticking of the clock is measured in the shifting chemistry of the core, a countdown that concludes the moment iron is forged in the centre. At that instant, the outward pressure vanishes, and the delicate balance that has sustained the star for its short, violent life is shattered forever. The end comes with a suddenness that defies the usual slow pace of cosmic time. In a fraction of a second, the iron core collapses under its own weight, shrinking from the size of a planet to the size of a city. This collapse creates a rebound of such unimaginable power that it tears space asunder, sending a shock wave rippling outward through the star's outer layers. This is the supernova, the final, spectacular finale of a giant's life. It is a scream of light that can outshine an entire galaxy of 100 billion stars. For a few brief weeks, the dying Titan becomes the most luminous object in the observable universe, a beacon of pure energy that carries the news of its demise across the vastness of the void. This explosion is not merely a visual event, it is a physical displacement of the universe, a moment where the internal contents of the star are violently returned to the interstellar medium. This terminal act is the most vital function of the star factory. If these giants lived forever, the universe would remain a sterile collection of light and gas. Their deaths are the necessary dispersal of the ingredients for everything that follows. In the heat of the supernova explosion, even heavier elements than iron are forged in the chaos. Gold, silver, platinum, and uranium are created in the final seconds of the star's existence and then hurled into space at a significant fraction of the speed of light. The factory is therefore a place where life and death are indistinguishable, a seamless cycle where the destruction of one generation provides the raw material for the next. The ash of the supernova, the clouds of carbon, oxygen, and iron, drifts through the nebula until it is caught in the gravitational pull of a new collapsing cloud, becoming the seeds for smaller, longer-lived stars and the solid planets that will eventually orbit them. The James Webb Space Telescope reveals this landscape as both a womb and a graveyard. The golden mirrors capture the silhouettes of newborn stars emerging from the very clouds of gas that were enriched by the deaths of their predecessors. We see the ghosts of ancient explosions in the form of expanding shells of gas, and within those shells, we see the next generation of fire beginning to ignite. It is a frantic industrial recycling program on a galactic scale. The time bombs of the early universe were essential. Without their rapid lives and violent deaths, the cosmos would have lacked the complexity required to build a world like ours. The factory does not mourn its dead. It consumes them, turning the tragedy of a dying sun into the opportunity for 1,000 new worlds. This realization brings a sense of profound continuity to the images captured by the golden eye. The blue-white titans we see in the distance are already gone, their light having travelled for billions of years to reach us, yet their legacy is present in every atom of our being. We are looking at a process that is both beautiful and terrifying, a state of perpetual transformation where the boundaries between the individual star and the surrounding universe are fluid. The factory is a testament to the fact that in the cosmos, nothing is ever truly lost. It is only rearranged. The scream of light that marks the end of a massive star is the same energy that eventually settles into the quiet, steady glow of a stable sun, and the heavy elements scattered in the void are the same materials that will one day form the bedrock of a planet and the architecture of a mind. The sentinel at the second Lagrange point stands witness to this eternal exchange, proving that the light of the beginning is still very much alive in the substance of the present. The revelation of this industrial titan has sent a shockwave through the hallowed halls of astrophysics, for it represents a fundamental violation of the cosmic timeline as we once understood it. According to the standard models of galactic evolution, the carefully constructed blueprints that have guided our understanding for decades, the early universe was supposed to be a place of slow and measured progress. We believed that the first galaxies were small, fragile things, mere sparks in the gloom that would take billions of years of gravitational mergers and steady accretion to reach a state of true maturity. We expected to see the infancy of the cosmos as a period of fumbling growth, a quiet dawn where the first structures were only beginning to find their form in the cooling wake of the Big Bang. Instead, the James Webb Space Telescope has revealed a landscape of impossible maturity, a frantic construction site where the laws of logic appear to have been suspended in favour of a terrifying high-speed creation. Finding this massive and efficient star factory so soon after the beginning of time is like stumbling upon a fully functioning modern metropolis in the middle of a prehistoric wilderness. It defies the expected order of operations. In our previous simulations, the universe at this age, less than 1 billion years into its existence, should not have possessed the gravitational infrastructure required to gather such a colossal reservoir of fuel. Yet, here it stands, a galactic structure of monstrous proportions, churning out suns with an appetite for creation that is nothing short of aggressive. It suggests that the early cosmos was far more energetic and far more efficient at processing its primordial gases than any of our theories had dared to predict. The architect of the heavens seems to have thrown away the blueprints of gradual assembly, opting instead for a violent, accelerated pace that leaves our current understanding in the dust. This discovery forces a radical rethinking of the history of everything. It suggests that the so-called dark ages of the universe, the long period of shadow before the first stars ignited, were shorter and more turbulent than we suspected. The transition from the smooth hot soup of the beginning to the complex structured reality of massive galaxies happened with a ferocity that points to a hidden mechanism of growth. Perhaps the invisible scaffolding of dark matter, the mysterious substance that provides the gravitational backbone of the universe, was far more concentrated and active in those early days. Or perhaps the first generation of stars was even more massive and influential than we modelled, acting as a high-octane primer that jump-started the industrial cycle of the cosmos with a level of efficiency that defies modern comparison. The frantic pace of this early factory poses a specific challenge to the concept of feedback. In the modern universe, when a region begins to produce stars at a high rate, the resulting radiation and supernova explosions tend to blow the remaining gas away, effectively shutting down the factory and regulating its growth. This is the natural check and balance of the celestial machine. However, in this ancient star factory, that regulatory system seems to have failed or been overwhelmed. The stars are igniting so quickly and in such vast numbers that the feedback cannot keep up. The factory is growing in spite of its own violence, consuming its fuel at a rate that suggests the early universe was a place of overwhelming abundance, where the sheer density of matter could override the forces that usually limit the birth of suns. For the scientist on Earth, this is a moment of both crisis and exhilaration. There is a beautiful tragedy in being proven wrong on such a fundamental scale. Every data packet that arrives from the golden eye is a hammer blow to the old consensus, forcing researchers to return to their chalkboards and rewrite the opening chapters of our cosmic biography. We are realizing that the universe did not merely wake up, it exploded into a state of hyperproductivity. It was a place of frantic, desperate construction, where the foundations of galaxies were hammered out in a fraction of the time we thought possible. The imagery of a slow, cooling expansion is being replaced by the reality of a roaring, high-pressure furnace. This shift in perspective changes how we view the entire lineage of the cosmos. If the universe was capable of building such massive structures so quickly, it means that the potential for complexity, and perhaps the potential for life, was present much earlier than we ever imagined. The industrial heart of the cosmos was beating with a full and heavy rhythm, while the universe was still in its cradle. As we stare at the glowing metropolis revealed in the infrared, we are forced to acknowledge that we are the descendants of a much more violent and efficient beginning. The Golden Sentinel has not just found a distant object, it has unmasked a flaw in our logic, a glorious inconsistency that proves the universe is always far more ambitious, far more chaotic, and far more creative than the small minds that seek to measure it. The history of the heavens is being rewritten in real time, and the new story is one of a frantic, beautiful, and impossible speed. The frantic brilliance of this industrial heart carries within it the seeds of its own inevitable silence. In the cosmos, as in any machine, there is a relentless tax imposed by the laws of entropy. The very efficiency that makes this star factory a marvel of the early universe is also its death warrant. By consuming its vast reservoirs of primordial hydrogen with such profligate speed, it is burning through its future in a single spectacular burst of light. The thousands of suns forged every year represent a permanent withdrawal from the bank of creation. Eventually, the thick, turbulent clouds of the interstellar medium will begin to thin. The roaring furnace of the Nursery will stutter as the supply of raw gas fails to keep pace with the insatiable appetite of the stars. The industrial metropolis of fire will, over the course of hundreds of millions of years, begin to dim, transitioning from a place of frantic assembly to a quiet archive of what once was. The future of this region is a slow descent into a celestial graveyard. As the massive blue-white titans exhaust their fuel and explode, they leave behind remnants that can no longer contribute to the cycle of fire. The factory will increasingly be populated by the cold cinders of the heavens. White dwarfs, the small and cooling husks of stars like our sun, will drift through the thinning gas like glowing embers in a dying hearth. More massive stars will leave behind neutron stars, objects of such incredible density that a single teaspoon of their matter would weigh as much as a mountain, or silent black holes, which act as permanent gravitational tombs for the matter they once commanded. The vibrant magentas and oranges of the infrared tapestry will fade into a uniform lightless grey. The metropolis of fire will become a city of ghosts, a vast collection of iron-cold spheres and invisible pits of gravity where time and light are swallowed whole. This local exhaustion is a microcosm of the fate that awaits the entire universe. We are currently living in the age of starlight, a brief and glorious window of time where the conditions are perfect for the ignition of suns and the flourishing of complexity. But this era is merely a flickering moment in the total history of the cosmos. Just as the star factory must eventually run out of gas, the universe itself possesses a finite amount of fuel. Billions and trillions of years from one moment to the next, the galaxies will drift further apart, the gas clouds will grow too cold and diffuse to collapse, and the last of the red dwarf stars will finally gutter out. The great nurseries that once defined the youth of the cosmos will be extinguished one by one, leaving the universe in a state of eternal darkness. This death of time is not a violent catastrophe, but a slow and inevitable cooling into the silence from which everything first emerged. It is the ultimate triumph of the void over the matter. Without the heat of the stars to drive the movement of gas or the evolution of chemistry, the universe will enter a state of maximum entropy. The temperature will drop until it sits just a fraction of a degree above absolute zero, and the expansion of space will have pushed the distant galaxies so far away that they vanish from each other's sight. In this far future epoch, the very concept of a star factory will be a forgotten myth, a relic of a time when the universe was young, crowded, and full of fire. The silence of the second Lagrange point, where the golden sentinel now stands, will eventually become the silence of the entire cosmos. The foreshadowing of this end is written in the very light the telescope captures today. By witnessing the peak of stellar production, we are also witnessing the beginning of the end of the fuel supply. The frantic pace of the early universe was a signature of its abundance, but that abundance is being steadily converted into the ash of heavy elements and the cold radiation of the deep. We are seeing the universe in its most productive hour, a period of history that will never be repeated. As the golden eye peers into the infrared, it sees the heat of a machine that is running at full throttle, knowing that every photon it gathers is a piece of energy that can never be recovered. The eventual cooling of the cosmos is the final chapter of the story that began with the Big Bang. It is a return to the state of perfect stillness, a world where the struggle between gravity and light has finally been resolved in favour of the dark. But there is a haunting beauty in this inevitable conclusion. It suggests that the light we see now is all the more precious because it is temporary. The star factory is not just a place of creation. It is a reminder that we are living in the golden hour of the universe, a time when the fires are hot, the chemistry is rich, and the mind is capable of witnessing the spectacle. The death of time will be the ultimate silence, but until that moment arrives, the universe continues to burn with a desperate, beautiful intensity, using every last drop of its primordial fuel to light the way toward an uncertain future. The sentinel remains at its post, a small speck of gold reflecting a fire that will one day go out, but which, for now, remains the most magnificent sight in all of existence. In the unyielding dark of the second Lagrange point, the James Webb Space Telescope remains a silent, shimmering testament to the audacity of a single fragile species. Its 18 golden hexagons, aligned to the precision of a light wave, do not merely function as a collector of ancient radiation. They serve as a mirror in which humanity is finally able to see its own prehistoric reflection. This machine is the culmination of a journey that began when the first hominids looked up at the night sky and wondered if the points of light were campfires of the gods. Today, we know they are something far more profound. They are the ancestral furnaces that forge the very carbon in our DNA and the calcium in our teeth. When we gaze upon the images of the largest star factory in the cosmos, we are not looking at a foreign object in a distant land. We are looking at the womb of our own existence, a visual record of the labour pains of the universe that eventually allowed for the possibility of us. There is a profound and quiet beauty in the realization that a species composed of soft tissue and water, living on a small planet orbiting an unremarkable middle-aged star, could conceive and build a device capable of looking back 13.8 billion years. We are a biological fleetingness, a collection of atoms that will persist for only a few thousand weeks, yet we have reached out across the abyss of space and time to touch the beginning of everything. The telescope represents the triumph of the human spirit over the limitations of the physical body. We are blind to the infrared, yet we have built an eye that sees it. We are vulnerable to the vacuum and the cold, yet we have placed a sentinel in the heart of the void. This machine is a bridge between the finite and the infinite, a tool that allows a mortal mind to grasp the mechanics of immortality. The journey into the dark does not end with the discovery of a single star factory or the mapping of a distant galaxy. In the realm of science, every answer provided by the golden eye acts as a key that unlocks 1,000 more doors, each leading to a new and more complex mystery. We find a galaxy that grew too fast, and we are forced to ask if our understanding of gravity is incomplete. We see the heavy elements scattered by a supernova, and we wonder how many other worlds are currently being assembled from that same ash. The telescope is not a destination, but a point of departure. It has shown us that the universe is far more crowded, far more active, and far more creative than we had ever dared to suspect. It has revealed that the emptiness between the stars is a lie, a product of our own limited senses, and that the cosmos is actually a vibrant, interconnected web of energy and matter. As the sentinel continues its long watch, it reminds us that we are not separate from the universe, but a way for the cosmos to know itself. We are the sentient remnants of the star factories, the part of the industrial cycle that has developed the ability to turn around and admire the work. This realization carries with it a sense of cosmic responsibility. If we are the eyes and the ears of the universe, then our curiosity is the most valuable resource in existence. It is the fuel that drives us to build cathedrals of glass and gold in the silence of space. It is the impulse that refuses to accept the horizon as a boundary. In the vastness of space and the immensity of time, our presence may seem insignificant, yet it is our ability to ask why that gives the stars their meaning. The golden eye will eventually grow cold, its fuel will be exhausted, and it will join the graveyard of cinders it was built to observe. But the light it has gathered and the truths it has uncovered will remain part of the human inheritance forever. We have seen the fire of the beginning, and we can never go back to the darkness of ignorance. The story of the largest star factory is a chapter in a much larger narrative, a story that is still being written by every person who looks at the night sky and feels a sense of wonder. We are a part of a grand celestial architecture, a living link in a chain of fire and ash that stretches back to the first second of time. In the end, it is our curiosity that remains the brightest light of all. As long as there is a mind to wonder and an eye to watch, the universe will never truly be empty. The journey continues into the deep red of the infrared and the far reaches of the unknown, where the shadows are thickest and the secrets are most profound. We move forward not with fear, but with the quiet confidence of a species that has learned how to see through the dust. The golden sentinel stands as a monument to our desire to know the unknowable, a gleaming speck of hope in the eternal night, proving that even in the face of the infinite, the human heart remains the most powerful engine of discovery in the history of the cosmos. The eye is open, the mirrors are aligned, and the universe is waiting to be seen.